So as mentioned in the email this video is attached to, Diane pulls a sled along a snowy path on level ground with her little brother Jasper riding on the sled. The total mass of Jasper and the sled is 26 kilograms. The cord makes a 20-degree angle with the ground. As a simplified model, assume that the force of friction on the sled is determined by mu sub k is equal to 0.16. Even though the surfaces are not dry, some snow melts as the runners slide along it. Find A, which is the work done by Diane, and B, which is the work done by the ground on the sled while the sled moves 120 meters along the path at a constant 3 kilometers per hour. And part C is what is the total work done on the sled. Well, to find the work done by a force on an object, we need to know the magnitudes and directions of the force and of the displacement of the object. The sled's acceleration is 0, so the vector sum of all the external forces like gravity, friction, and the tension in the rope, and the normal force are all going to be 0. And then I drew my force body diagram up here to describe the image and show where the forces are. So the force body diagram shows that the x and y axes are parallel and perpendicular to the ground, respectively. And after resolving the tension into its components, I applied Newton's second law with 0 acceleration. Gives me these formulas here, which is the sum of the forces in the x direction is equal to the positive tension cosine of angle theta minus f sub k is equal to 0. And then the sum of the forces in the y direction is equal to positive tension sine of angle theta minus mg plus n is equal to 0. And well, this means that T is in tension and the angle is 20 degrees. So the force of kinetic friction is F sub K is equal to mu sub K times N. And then all I did was substitute this equation into the first equation, which is the sum of the forces in the x direction, to get the tension of cosine theta minus mu sub K times the normal force is equal to 0. And then from there, to find the tension, we need to eliminate the unknown normal force N, and we do that by combining the second equation and multiply it to get the mu sub k times tension times sine of angle theta minus mu sub k times mg plus mu sub k times n is equal to 0. And then adding this third equation and the fourth equation also eliminates normal force, and then we are able to solve for T, which is T cosine of angle theta plus mu sub k times tension times sine of angle theta minus mu sub k times mg is equal to 0. And we set T equal to mu sub k times mg divided by mu sub k times sine of angle theta plus cosine of angle theta. And I plugged in my values for that, and I get it as 41 newtons. And now that we know the tension, we can find the work done by Diane. And the component of the tension T acting parallel to the displacement is T sub x is equal to T cosine theta, and the displacement is change in x is equal to 120 meters. So the work done by Diane is equal to this formula here, which is W sub T is equal to T times cosine of angle theta times the change in x. And all I did was plug in my values for that, and I get that is equal to positive 4,600 joules. And then for part B, the force on the sled due to the ground has two components, the N and the F sub K. And the normal force doesn't do any work since it is perpendicular to the displacement of the sled. Now friction acts in a direction opposite of the displacement, so the angle between the force and the displacement has to be 180 degrees. And the work done by the friction is given in this formula here, which is W sub F is equal to F sub K times the change in x times cosine of 180 degrees is equal to negative F sub K times the change in x. And then from there I got F sub K is equal to the tension times cosine of angle theta. And this means that the work done by the ground, the work done by the frictional force, in other words, is going to be our formula here, which is W sub F is equal to negative F sub K times the change in x is equal to negative tension times cosine of angle theta times the change in x. And this gives us W F sub F is equal to negative 4,600 joules. And then moving on to part C, the tension and the friction are the only force that do work on the sled. So the normal force and gravity are both perpendicular to the displacement. So they do zero work. So this gives us the equation W sub total is equal to W sub T plus W sub F is equal to 4,600 joules plus negative 4,600 joules, which again gives us our value of 0 because they both do zero work.